Hi, Jonathan. I don't think we saw you in the meeting before. Can you introduce yourself a little bit?
Hi, my name is Jonathan Burkhardt. I work for IBM as an open source contributor to Kubernetes. Specifically, I work on the service catalog project under Doug and with Morgan Bauer, who should be here in a minute.
Cool.
Yeah, Morgan and Jonathan decided to join in the conversation about this irreversible delete stuff.
Okay, great. Okay, I think we can start. So first of all, some update. So the KubeCon Shanghai, I think all the session confirmation have been sent out. So for the working group, we again, similar to Copenhagen, we have an introduction session and deep dive session confirmed. So if you guys will come to China, and you're more than welcome to give a talk at either these two sessions. And for the KubeCon Seattle, the deadline has passed, I think. So I think the review will begin very soon. And regarding the CNCF level, the policy and safe, me and Erica, and we're working with Dan and JJ and those safe folks to get this going. I think everything is on track. The planned TOC review is next week, I believe. So again, on Thursday, we'll have another meeting to hammer some more details out. So I think that's about it. Okay, today we invited Doc Davis here to give us a discussion about a quite interesting topic. Doc, do you want to share the screen or?
Yeah, that's fine. I can share, or you can click on that second link in the slides. Either way is fine with me. It's only 2 slides, so it's up to you.
I think you can share. Let me start.
Okay, sounds good.
Okay.
Let's see. All right, can you see that?
Yep.
Okay, excellent. Actually, let me do this. Excuse me. So before I start talking about the slides, so the reason we're here is because the service catalog was facing an issue, and it was suggested that perhaps we go to SIG architecture to discuss it there to see if they had any, wonderful guidance for us. And for the most part, they basically pointed us to the community to see if other people in the community were having similar issues. And so I sent a note out to the community asking if there were other people running into these same problems. And as a result of those email threads or discussions, someone basically suggested that we go to your policy working group, because it sounded like it may be something you guys want to look at or possibly try to tackle, and maybe this is the right forum to discuss it and potentially see if there's a possible solution. So that's kind of why we're here. They may be wrong, maybe this isn't the right spot for it, but we'll see how it goes. So let me talk about the problem that we're facing. So in SIG Service Catalog, and you don't need to necessarily understand what Service Catalog is doing. All you really need to understand is that the Service Catalog talks to or integrates with a third-party system. In other words, things that are called service brokers. And the Service Catalog will talk to the service brokers to do CRUD-style operations on resources within those brokers. And it does these requests based upon Kubernetes users asking them to do so, right? So the Kubernetes user will say, create a new service. Service Catalog will then talk to the service broker to provision the new service, and then you can update it, delete it, stuff like that. Pretty basic stuff. The important thing to understand here is that each request from the Service Catalog or Kubernetes to the service broker will have a user associated with it. In particular, it will be the Kubernetes user that caused that request to happen. Okay, and that's interesting information, but it's also very important, and we'll talk about why that's important later on. So, from the service broker's point of view, when they get these requests from Kubernetes, they can reject the request for a whole variety of reasons. Okay, there isn't just one particular reason. It's like any other backend system. They could be down, they could accept the request, but then reject it because of authentication reasons. The person may not have the right access control rights. There could be complicated business processes involved in terms of who and when this operation can be invoked. So for example, maybe this operation in general can happen, but maybe not by this particular person at this particular point in time. Maybe in 1 hour they can. Maybe they'll never be able to do it. We don't know. The point is, there could be complicated business processes involved here in making these particular decisions. And so realistically, the only way that we're ever going to know whether any particular operation will be not only just accepted by the service broker, but even allowed to happen is until we actually try the operation itself, okay? So let me sort of pause there and see if that makes sense so far. Does that make sense, everybody?
Yeah.
Okay, cool. So when the broker chooses to reject a request, there's almost two different types of requests that we're actually really worried about. One is update and the other one is delete. Update has a whole bunch of problems with it, but for the most part, for the purposes of this discussion, we can assume update isn't that big of a deal, because if the broker rejects it, the Kubernetes user could technically go back and update the spec in the Kubernetes resource to undo the change or tweak it so that the next time the request happens, it will get accepted, right? They can still basically touch the resource and make some sort of changes to hopefully try to recover from the situation, okay? So we can ignore update for the purpose of this discussion. The real problem comes into a place when you start talking about delete. Because as I'm sure you guys all know, once Kubernetes says that the delete is allowed to happen from its point of view, meaning it can update the spec to set the deletion timestamp, it's a done deal, right? Kubernetes will not allow you to roll back a delete or undo a delete or anything like that. So when the service catalog controller notices that the deletion timestamp has been set, it will then, as you might expect, try to talk to the broker. And if the broker looks at that and says, nope, sorry, this user is not allowed to delete at this particular time, go away. I'm going to reject your request. The service catalog or Kubernetes is now in a bad state or in a bad situation, right? Because it can't undo the delete, but the user now can't use this resource. So it basically becomes an unusable resource, even though technically this operation never should have been allowed to happen in the first place from a global perspective, right? Not just from a Kubernetes perspective or anything like that, but from a global end user perspective, their request should have been rejected at some point in the processing and not leave things in a state that's basically unusable, okay? That's kind of the situation that we're in. before I move to the next slide. Does that make sense so far?
Quick question. Does the broker have a sort of delete dry run or way of saying, can this delete happen without actually following through with it?
Right. So let me get to slide 2 because that's an excellent question, and that is one of the things that we've talked about. Actually, wait a minute. Nope, sorry, I don't talk about there. Let me answer your question directly. I apologize. The short answer is no. There is no operation defined as part of the service broker specification called dry run. However, even if we did have a dry run operation, it probably would not solve the problem because there's no guarantee that just because the dry run says yes, that the real operation will also say yes, right? There could be some magic bit that gets set between those two time periods where suddenly the real operation fails. And so there's no way to guarantee that a dry run is like, guaranteed for whatever length of time you want to assign till the time the real operation is invoked. So that's one of the problems with the notion of a dry run. All right, any other questions?
So may I ask a question regarding the service catalog? I'm not quite familiar with service catalog. So as you just mentioned, the deleted basically performed from user first. The user is going to issue a delete operation on the Kubernetes resource. And then the service catalog controller will then call the broker to perform the real delete operation. Is that correct?
That is correct, yes.
And this also true for update, right?
True, yes.
Okay, I understand.
Yep. Yeah, and it's that sort of disconnected world, for lack of a better phrase, that's causing the problem, right? Because Kubernetes has its own set of checks, whether it's RBAC controls or admission controllers or whatever, right? It has its own set of checks, and it's not possible to include or to model all of those potential business processes that I talked about earlier, right, up here. It's not necessarily possible to model all of those rules in RBAC rules or as admission controllers, right? And so that's part of the problem here is they have this sort of, I want to call it almost like, almost want to do like sort of delayed delete kind of a thing. But anyway, I'm sorry, go ahead and ask your question.
Yeah, so this seems to me is a very common problem people meet in, especially integrate multiple system together when they are talking different like APIs or whatever with different authentication or permission checks stuff. Even in a case when an API is unreliable and when called to a service which fails in the middle kind of stuff, I think this is a very, very common problem in this system.
Yeah, I would tend to agree, and that's why I was really hoping to have a broader discussion with the appropriate people within Kubernetes to brainstorm on ideas on how to solve this, because there is no good way to solve this right now, right? Because the typical response that we've heard from people are things like, well, add an admission controller, right? And as I said, the admission controllers are problematic because, one, you may not be able to model or duplicate all the business processing rules inside the admission controller, right? Because trying to replicate potentially very, very complicated logic someplace else is always error prone. But two, the admission controller is almost then acting as that dry run that I talked about, right? And there's no guarantee that just because the admission controller says yes, that the real operation will ultimately also say yes, because there's always going to be some sort of time delay between the two. And so you never know what's going to happen. And so ultimately, in my opinion, Kubernetes always needs to be prepared for any operation to these back-end systems or third-party systems it needs to always be prepared for those operations to say no and fail for some reason. And at least in the delete case, if the only recourse for the user is to say, okay, well, it failed, but tough, you got to delete the Kubernetes resource, that's not necessarily a great user experience, because that means the user almost should never ever try to delete, because if it fails, well, they can't back it out, right? So it's a weird situation. Anyway,
I also like to read that it's a potential problem that if the delete fails, which could happen not necessarily for business logic reasons, like the connection to the broker could go down or something, things could get dropped. that irreconcilable state could be a potential problem because, for instance, if they were, deleting some large service instance like a database or something, as far as Kubernetes know, it's gone, but it still exists in the backend and they could be getting charged for it or whatever. And there's no path forward through Kubernetes for that user to reconcile from that state. They have to go out of band, and that's what we're trying to avoid.
Right. All right, so just quickly, I thought it would be important to enumerate some of the options that people have brought up to us to try to solve this, and very briefly talk about sort of the problems with each one. I've talked about some of these already. So for example, RBAC rules. It's not possible to map all the complicated business logic that we've actually seen out there in the wild as RBAC rules. And I've already talked about admission controllers, right? Hard to model all those, or it's error prone to duplicate that logic into admission controllers, and it becomes like a dry run operation, which isn't necessarily guaranteed for things. We talked about things called like shadow resources. This is the notion where we actually create sort of, in the Kubernetes model, two different, almost like service instances, right? One which is the shadow, and one is the real one. And so when the user issues delete, if it fails and we get to this weird state, well, it's no big deal. You just delete the shadow, create a new shadow, but the real one still lives on, right? And that's problematic, because then you get into this weird state where people are watching one of those resources but not the other. And let's say they actually take an action based upon the shadow resource being deleted, thinking, oh, well, that one got deleted. I can now take some cleanup action, right? And if we end up recreating the shadow resource, then you have to somehow undo that cleanup action, and it gets very, very messy. And it just, every time we talked about that one, everybody sort of said, yeah, it's technically might be an option, but it just seems so complicated and error prone, it's just not even worth considering. The delayed delete option is one that we talked about, which I thought was kind of interesting, which was make the normal Kubernetes delete, rather than setting the deletion timestamp before it returns back the 202 to the client, have it set some other flag that the controller then notices and can then try to delete in the backend system. And if it works, then it sets the deletion timestamp. So that way, the reason I call it delayed delete is because what you're really doing is you're delaying the setting of the deletion timestamp until the backend system says, yes, it's okay to do it. And people didn't necessarily like that one, because a lot of people believe that a 202 on the kube control delete means the deletion timestamp has been set. And there was some debate about whether that's really what it should mean, as opposed to just it's been accepted, but it's not necessarily guaranteed. But the general consensus from most Kubernetes gurus was deletion timestamp is supposed to be set when that 202 comes back. So that's why that one was kind of rejected. The other option we talked about is similar to delay delete, which is we have another flag, but people explicitly set the flag. So it's not hidden under the kube control delete. But in order to make that work and consistent, we'd have to, in essence, disable the normal delete operation. So you can never do an HTTP delete. You'd always have to do a put to set this flag, and then the processing I talked about under delay delete would happen. The problem with this, of course, is that means you can't just do a normal kube control delete, right? You'd have to do a kube control update or something like that to do a delete, and that feels kind of funky, but it can technically work, right? So those are the options that we talked about. I'm not necessarily sure that I necessarily wanted to dive deep into which ones of these may or may not work. I think the high order question for you guys, aside from, are there any questions I can answer about the situation? Is this something that you guys would like to work on with us to brainstorm on potential ideas, or do you think this is out of your domain for the policy working group? Stunned silence.
My gut reaction is that this feels like something that should probably be owned by the API machinery SIG rather than the policy working group.
Okay. So far, the reaction from them has basically been tough, kind of.
Yeah. Hi, Doc. And
yes, hi.
This is Klaus. Yeah. So I think for this, for such kind of interaction between the different components, I think this is a common issue for the Kubernetes or the distributed system. And So I think we only miss the something about delete, right? Delete, update, something like that.
Yeah, delete
Or
is
do we
the
have
biggest
one?
problem. Yeah, delete is the biggest problem. Update has some other problems with it, but I think delete, if we could solve that one first, update may come easier.
Yeah. In scheduler, I think there for scheduler there is an extension plugin, so you can do HTTP extension to work together with the scheduler. One example is some people using this feature, and they do try to resync the information between the default scheduler and the extension. I think this is this issue is common. Also, we just delegate this requirement to the user. For example, they have to handle such kind of issue themselves. But I think this is something we need to handle in Kubernetes.
So I'm not sure I followed. Can you repeat what you said about the scheduler? Are you saying that the scheduler has a very similar problem?
Oh, the scheduler has a feature called HTTP extension. So you can do another plugin similar to your third-party system. So the default scheduler will communicate with this third-party system to make the decision how to allocate the resource.
So that's interesting.
Yeah.
But so in that particular example, I'm trying to figure out whether that's a similar enough use case that we could learn something from it, because in the scheduler situation that you're thinking of, do you have a situation where something can have its deletion timestamp set, and then this interaction with the third-party system can try to reverse that?
Yes, I think for scheduler, an important thing is that the state or the status of cluster is interval. For example, they can resync the status between the API server, so they can make if they find something unstable, they can resync the status.
So when you say resync the status, does that imply that they could actually undelete something?
Oh, they depend on the data in the API server.
Because I was under the impression that once the deletion timestamp has been set, you can't reverse that.
Oh, no. If something delete handle if the object is delete, the API server the plugin cannot revert it. They just follow the status.
Right, and I think so that might be a slightly different scenario then, because I think the situation we're running into is we can't according to the people who understand the API server, we're not allowed to make an HTTP delete not set the deletion timestamp, but at the same time, we also are not allowed to unset the deletion timestamp. Right, so we're in a situation where we're not allowed to we're not allowed to block the deletion, but we also can't reverse the deletion, and we need to somehow, or we need to somehow get out of that sort of catch-22 situation. Does that make sense?
Yeah. I'm thinking how to. I'm thinking whether how to handle this in our product. Yeah, I think we need. Let me think for a while. Yes, okay. maybe yes, maybe. Do you have some issue or some slide to discuss about this one?
Well, we have an email thread, and I think it's in the meeting minutes. You're welcome to
in the Google group.
Yeah, in the meeting minutes, I believe. Where is it? Let me just double check. I think this was the email thread.
Okay. Let me thinking about this, because in our product we also have a similar issue. because such kind of issue is really similar, and we also yes, I will open something here.
Okay. Yeah.
Maybe summary something. Yeah.
Yeah. So I guess one question I'd like to understand is the scope of the policy working group, because I think one of the reasons people pointed us to this working group is because they kind of viewed this as how to handle sort of external third-party systems having influence over policy decisions. At least I think that's the way they were thinking of it, and that's why they sort of pushed us your way. If you were to think of this problem from that perspective, do you guys think this may be something that does fall into your domain, or still, because ultimately this is going to require an API server change, really that's the proper SIG to discuss this?
I think actually one of the aspect that if we look at policy could help is on the delete suggestion you have, right? So it might be possible to have, for example, define a policy object that tagged delete so that you won't affect the normal delete API or operation. So you still perform the delete, but you tag either the pod or the workload with a policy that these pods are tagged delete, meaning that when user perform delete, actually will just, for example, queue it or record it or cache it, right? Until the service broker responds with a success, then we actually delete it. Yeah, but I think this might be a way that actually having a policy to help solve the situation, but we'll still be needing to figure out the problem you just mentioned, that Kubernetes, I think it will involve to figure out a way that getting into the current Kubernetes way of delete so that we could have, like I said, something like queue or cache that just record the operation without actually performing it, and then perform it, with the confirmation. Yeah.
Interesting. Yeah, I think you're right that if some sort of policy thing like that may actually work for us. I need to think through it, but it does sound like it has some possibilities. I think based upon our experience so far, I think the challenge with that is going to be convincing the rest of the Kubernetes experts that that's an allowable action, because it is a change to the normal workflow, right?
Yeah.
Yeah, that might be a very large uphill battle.
Yeah, but I think this should be a universal problem. Anything that extends Kubernetes core functionality, will face this problem.
Yeah, I think Doug. I think one thing is that for the communicate between the component, a total reliable action, I think that's will be really hard. We need to, but in other way, if we have some toleration for each component, maybe some practice for each component, how to handle such kind of issue. I think that will be easier to implement.
Yeah, and I like the way you described the problem, right? Having some sort of toleration for failures, because not every message is going to be successful every single time, right?
yes, because even we in logically this work, but there may be some network issue, some hardware issue. There will be lots of issues here. There may be so error handling in the distributed system is really hard. So but I think that's a good topic. But we can follow this topic to give some practice or some guidance how to communicate between the different components.
Right, and just to follow up on that, I'm playing devil's advocate here a little because I'm trying to anticipate some of the things like I imagine people will say, and I think one of the things we've heard in the past is, well, even in the failure case,
Yeah.
Kubernetes should still just retry the delete over and over and over because
Yeah.
Kubernetes is the source of truth, and the problem is, as you can see in the situation here, Kubernetes may be the source of truth in terms of what this particular user wanted to try to do, but it's not necessarily the source of truth in terms of the state of the overall system.
Yeah.
And what's allowed to happen. And that disconnect there is something we're trying to figure out, how do we reconcile?
Well, actually, I think there's two problems. One, I think we already discussed is distributed system problems. I think which is out of scope of policy working group and can be discussed with API machinery. And actually, there's the other problem is a special use case when the delete happens. The current user doesn't have a permission to delete, and then the delete is called on a broker, and which rejects the delete. But at that time, the irreversible delete is already happening on Kubernetes. That's actually a problem which surfaced to be a topic we can discuss in policy working group. And basically, also broadly, it's a question about how we can populate the permission problem from a third-party system into Kubernetes. Because it's kind of like a precondition for all operation. It's even different from the distributed system problem. So the deletion should first go through the accurate or precise precondition process and make sure that everything can be happen and can pass through before the call actually hit the broker or the certified system.
Yeah.
So that's, I think, was discussion in the policy working group.
Yeah, that's interesting. Thinking of it in that perspective, let me reword it in my own words to make sure I understand what you're saying. It sounds like what you're saying is, in the abstract sense, allowing Kubernetes to have a third-party policy checking system in place that will allow you to verify all incoming request messages against that third-party system is a very generic problem.
Yes.
And you need to be able to solve that problem, especially in the case where maybe talking to that third-party system may not be an immediate operation, right? It may be a long-running operation, so you need to do it asynchronously. Therefore, you need to be able to solve that problem in general case. And once you solve that in the general case, then this delete just magically works, because the delete will, in essence, be blocked until you can talk to the third-party system to verify that it's okay. And once the third-party system says okay, then the delete can continue and set the deletion timestamp. And
Yes.
so I like the idea of thinking of it as a asynchronous third-party policy checking system.
Yeah, policy check, basically.
Yeah, I like that.
Because it completely results in two different use cases. So if a user is allowed to delete, it performs the delete. Whatever it failed, regardless of whatever problem, like even networking or whatever problems, we can still safely mark the resource as with deletion timestamp, and control just keep delete the resource because it's allowed. It's okay. But if the deletion failed because of users not allowed, we have to reverse the operation because it's better to fail at the beginning.
Right. Yep. No, I like the way you phrased it. I agree with that. That's good.
Yeah.
Can you just do that today with a validating admission webhook?
I'm sorry, say that again?
Can't you just do that today with a validating admission webhook? Where, yeah.
But the problem with that is it assumes everything's synchronous, right? So if the request to do the actual delete to the backend server was called through an admission controller or a verifying webhook, if during that time it's a long-running process, if Kubernetes recycles, you're going to lose the fact that the operation tried to happen, and it's not going to get restarted or picked up where it left off or anything like that.
Mm-hmm.
It assumes everything's synchronous, and that's the problem.
Mm-hmm.
But you're right, though. If we could make that asynchronous, I think we may be able to work around this problem. But unfortunately, right now, I don't think you can.
One other thing worth mentioning is we had a conversation in SIG architecture last week about the idea of kind of binding the life cycle of two Kubernetes resources together. So we're talking about kind of extending core resources with CRDs that sort of exist in parallel to the other resource. And then you run into a similar problem where, like, what happens if you just delete one of those resources? How do we sort of protect the other one and kind of maintain that relationship? And it feels like there's some kind of related problems there and maybe a common solution.
It could be, yeah. That almost sounds similar to that shadow resource thing that I was talking about, where
yeah,
the synchronization or possible confusion of who's watching what resource when could pop up and be an issue. But yeah, it sounds similar. Okay, so what's the next steps here? It sounds like, Klaus, you were going to possibly add some comments to that email thread.
Yeah.
And then the notion of this being a generic third-party verification system call kind of thing, which I would agree would fall within the domain of the policy working group. Is that something that you guys would like to talk more about? Because I would love to have us brainstorm with you on ways to solve this.
Yeah, definitely. Well, from my side.
Okay, so what's the next steps here then from that perspective? Is it
so shall we continue discussion on the thread?
Okay, that works.
Oh, sorry. I think we can give a Google Doc to summarize our option and the user case. So if everyone agree on the option, or maybe what's our next step, we can have a pull request in the maybe we can have a proposal in the community or maybe some other place.
Okay. Yeah.
Yeah, I think that will be. Yeah.
I think a Google Doc would be good. Yeah, if you guys create a Google Doc, I'd be more than happy to try to populate it with something.
Yes, and then we will have a final, maybe a kind of final decision. For example, which option is better right now, or which what's the scope of the maybe some project or something. Yes.
Okay.
Yeah.
Good.
Yeah, just a heads up, the free 40 minutes will run out really soon. There's a second link. So
should we click it now?
yeah, maybe.
Okay, let me click it.
Yeah, let's switch over.